Well, how about this one? I'm asked to evaluate the sine, cosine, and tangent of the angle negative pi over 2 without using a calculator. Well, if I wanted to put this angle in standard position, and because it's in radians, I mean a standard position between 0 and 2 pi, well, I could add 2 pi to that, which is the same thing as 4 pi over 2. So that's going to be the same thing as 3 pi over 2. Reference angle. Well, the problem here with the reference angle is that this is not one of our reference angle positions, right? We cannot write an acute angle or an obtuse angle that fits it. This is, in fact, a right angle that terminates on the negative y-axis. It is a quadrantial angle. And the way I always remember what happens with my quadrantial angles is that since I'm pointing on the negative y-axis right here, I can think about my values for that angle. Well, what do we say about the quadrantial angle? Well, if we were to take the sine of 3 pi over 2, it would be the negative of the sine of pi over 2, which is to say negative 1. If I were asked to evaluate the cosine of 3 pi over 2, right, you remember the coordinate point here, if this was 0, negative 1, the cosine would be equal to 0. And of course, tangent, well, tangent of 3 pi over 2 is the sine of 3 pi over 2 over the cosine of 3 pi over 2, so we would call that value undefined. So as long as we know what happens at a quadrantial angle, usually at a quadrantial angle, sine or cosine is 1 or negative 1, and cosine is 0 or one of those. And then the tangent or the cotangent is always undefined. So we can get some places where we can do that. Quadrantial angles are one of those special angles where we don't have to determine anything about the reference angle, but we do need to know the sign that corresponds to that angle. So in standard position, negative 1, 0, and undefined.